Well, everybody, we're getting ready to start 5.5. This is standard form and also talking about our intercepts. We've talked a little bit about our x and our y intercepts, mostly our y, since it's really used a lot, and that y equals mx plus b, where b is our y-intercept. Yeah, we've talked a lot about it, but we're also going to start to incorporate our x-intercepts, learning how we can solve for them, how it's needed, how do we actually evaluate for them. And of course, all of that comes to we need to start to think about equations. While we have that equation, y equals mx plus b, the slope-intercept formula, we can manipulate it and move it around to suit our needs. And part of that is called standard form. One way we can manipulate that formula is if they give it to us or we need it in standard form. Or maybe if we're given standard form, we can turn it back into slope-intercept form. So let's take a look at this. Standard form for a linear function looks like this equation right here. It's ax plus by equals c. Basically, we have all of our variables on the left-hand side. A, b, and c are real numbers. So maybe it's like 2x plus 3b equals -4. Great. That would be standard form. All we do is we make sure that if it's not in that form, we move the pieces that we want all to the left. So any piece with a variable gets moved to the left. Any whole number, any constant gets moved to the right. And of course, we do that using the addition or subtraction property of equality. Again, standard form of a linear equation. Now, we use it because sometimes it is easy to find our intercepts, or we need to manipulate things back and forth, help us figure this out, okay? Think about this. We have talked about our y-intercept. Our y-intercept is our initial value, or when x equals 0. For a function, what is f of 0?
For the teacher who is tutoring for English honors, please contact the front office. The teacher who's tutoring English honors, please contact the front office.
And sorry about the announcements. It is what it is. As we look at this, okay, we need to be able to evaluate this. So they want to know what is f of 0, or what is our y-intercept. When our x is 0, what does y equals? So in this case, we're going to substitute a 0 here for x. 0 times 3 is 0. And 0 plus 2 is 2. So for this equation, our y-intercept is 2. Or we could say it is the coordinate. When x is 0, the y is 2. That is our y-intercept. Now, we have yet to formally be introduced to quadratics, but it works the same here for this one, right? We simply need to plug in our 0. All right, I'm going to substitute my 0 for the x. And again, I'm going to substitute my 0 for the x. Well, this turns to 0. 0 squared is 0, and 0 times 3 is 0. This all goes to zeros. And 0 plus 1 is 1. So again, this coordinate, my y-intercept, will be the point 0, 1. Notice that it's the constant. In our equation, our constant is always our intercept, or our c. Okay, so it's interesting to see how this works in our equations and how it plays out. In turn, if we need to find our x-intercept, that's a little bit trickier. We really deal with this a lot later on in the year, but just so you can see how it works, if they tell us, like maybe on our next PMA test, here's the function f of x, and it equals this. They want to know what are our x-intercepts. Well, we use, again, we've talked about this year, the zero product property. It says if the product of anything equals 0, because, again, we're trying to find the x-intercept, that means we're plugging in a 0 for y. So if f of x, remember, f of x is a really fancy way of writing y. if we're looking for that, right, we're plugging in a 0 for y. So the f of x becomes 0. Oh, now we suddenly have the product of two things equals 0. We can set each piece equal to 0 and solve. I need to subtract 4. So x is going to be equal to -4. There's one intercept. Okay. That would be the coordinate of my x-intercept. And same thing here, add 3. And this would be my other coordinate of my x-intercept. So again, you're using the zero product property to solve these if they already have it in this factored out form. And we'll talk more about this in another chapter, but you never know when you might see this. Intercepts are key for graphing horizontal and vertical lines. Again, we have Mr. Slope over here, right? A vertical line is his nose. The only points that it's going to be able to, we can even do is where does it cross the x-axis? The horizontal lines, where does it cross the y-axis? Vertical lines are the equation x equals, and x equals, where does it cross the x-axis? It has an undefined slope. That's what the U symbolizes. So we don't have a slope to put it in that slope-intercept formula. So we have to be careful about that. We look at the graph. Again, a graph might be something that looks like this, right?
This is the second call for Wiley Waggle. Wiley Waggle, if you're
Sorry about that again, more announcements. So if this is your graph, 1, 2, 3, and you have a vertical line crossing the graph at 3, your equation would be x equals 3. Again, over here, if you had something that was like the y-axis, looks like the mouth, right? If this is our graph, it's -1, -2, -3, and you have a horizontal line that crosses at -3. Our equation would be y equals -3. And again, there's some more graphing on these if you graph them really quickly. And this is not rocket science on these graphs. -1, -2, x equals. It is a vertical line that crosses at -2. And the y equals graph. The horizontal line that will cross the y-axis at 3. There's your y-axis and the x-axis. There's your y-axis and the x-axis. Guys, they label these, so be careful. X crosses the x, the y crosses the y. Now, the other thing we need to know in this section is it's about this whole, how do we transfer? Because remember, we said we like doing graphs in slope-intercept form. What happens when they give us the equation of a line in standard form? Well, that's not easy to graph. I can't look at that and just see what is my y-intercept. I can't see what my slope is so that I can put it on the graph.
Coach McCone and Miss Van Pelt, please go to A4. Coach McCone and Van Pelt, please.
Yeah, I apologize in this video. This is the worst interruptions I've had trying to do one of these of all the ones I've ever done. And here we go. We are going to look at this. We're trying to finish this out now. As we do this, right, we need to be able to get it into slope-intercept form. We want it in this form, this y equals mx plus b. Notice, these are not solved for anything. We want to solve these equations for y. We want y to be by itself. So, again, we're using all of our properties that we did from chapter 2. Let's solve this equation for y. I'm going to subtract a 3x. Notice, these are not like terms. I cannot combine them. Just rewrite. I have 2y is equal to -3x plus 4. Oh, this is starting to look more like our slope-intercept form. I just need to get rid of the 2. I'll divide it. I'll divide each piece by 2, and I reduce. These cancel, leaves me with a y. This is already reduced, so the slope is -3/2. And like that, see how our equation just starts to forming? 4 divided by 2 is 2. So now we would be ready to graph this. Our y-intercept is 2. Our slope is -3/2. There you go. Pause your video, try the next one on your own, guys. All right, let's see. Did you guys get the same answer as me? We are trying to solve here for y, so I am going to add a 2x to both sides. My scale's keeping organization here, so we'll have a 2x minus 3. These are not like terms. You cannot add them. You can just rewrite them. These canceled, and I'm left with a 4 and a y. Now, I have to divide every single term by 4. And these will cancel, leave me with a y equals. This reduces to 1/2 x. This doesn't reduce. So notice this time. We don't have a nice, perfect, pretty y-intercept. Sometimes that happens. That's why it's good to be able to manipulate these formulas, because you're able to see, hey, my y-intercept isn't something that's easy to graph. It's not easy to graph -3/4. That's somewhere in between. So it's good to see this. You never know how they're going to ask it, but we should be able to take an equation and solve for y. You're going to use this in every math class from here on out. All right, guys, that should be it for today. Make sure you do your homework. Take this time, utilize your time in class. Get your homework done. Work on any of the other assignments that you haven't finished. Have a fantastic day.